So let's talk about the discriminant first, okay? And what we're going to do to talk about the discriminant, I'm actually going to show you the quadratic formula. So the quadratic formula is a way to find the solutions, okay? So we have x equals, all right? It's a way to find the solutions of a quadratic equation. Okay, this only works for quadratic equations, thus it's called the quadratic formula. Okay, and here is the formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Yes, it is the quadratic formula. All right. Why do you hate it? Oh. Yeah, so it's kind of a mess, right? There's lots of things here, right? Lots of like variables, and then the simplification, right? We got square roots and things, okay? It makes things kind of tricky. Where do these A, B's, and C's come from? They come from okay, A, B, and C right there. Okay, so this is a quadratic equation in standard form. Okay. So we take the A, the B, and the C, and we plug them into their spots right here, and then we simplify this. Okay? But we're going to hold off on actually doing that work just for now, because Patrick says he hates it. All right? We'll give him a break for right now. It's terrible. All right? What we are going to look at, though, is this right here. This little bit of it that's inside the square root. And this little bit inside the square root, this is known as the discriminant. Okay, now, discriminant, all right, sounds like what word? Discriminate. That's right, okay? And you guys probably have some sort of idea about what discriminate is, right? Most of the time it's used nowadays. It's got like a negative, kind of like feeling to it, a negative connotation, right? But it's only negative, I guess, if you are discriminating based off of, I don't know, things that aren't good or whatever, okay? But this is going to help us discriminate, okay? And what does it help us discriminate? It helps us to determine or discriminate how many solutions happen in a quadratic equation. How many solutions a given particular quadratic equation will have, okay? Now, it tells us how many, right? The discriminant will tell us how many solutions there are. It will not tell us what the solutions are. That's why we need the full quadratic formula for that, okay? So the discriminant used to determine the number and type of solutions to a quadratic equation. Okay. The number and type of solutions to a quadratic equation. Okay. So, and here's how we're going to use it. All right. If b squared minus 4 times ac is greater than 0, and again, the b squared, the b, the a, and the c all come from our standard form quadratic equation right there. A, b, and c. A is the coefficient of the x squared term. B is the coefficient of the x term. C is just the constant term there. If you do this calculation and it's greater than 0, that means we have 2 real solutions. Okay, 2 real solutions. Okay? If b squared minus 4ac is equal to 0, then we have one and only one real solution. Okay, and if b squared minus 4ac is less than 0, then we have two solutions again, but it's two non-real solutions. Okay. Now let's think about this, and I'll kind of think about it from the last one we just talked about first. So we'll talk about this one, okay? B squared minus 4ac less than 0. If something is less than 0, that means it is what? We could call it what? If a value is less than 0, it is negative, right? Negative, okay? Now, take that b squared minus 4ac, which we know is negative because it's less than 0, okay, in this situation, and let's look at it up here. If b squared minus 4ac is negative, and then we have to take the square root of that negative number, what is the square root of a negative number? What kind of number is that? If it's square root of a negative, what kind of number is that? Square root of a negative? Nope, not positive. What do we have to use when we take the square root of a negative number? I. And what does I represent? What kind of number? Imaginary. So that's why b squared minus 4ac, if it's less than 0, if this quantity is negative and then you square root it, that's why you get two non-real solutions, because real numbers, you don't have square roots of negative numbers, okay? Real numbers are not square roots of negative numbers, okay? So that would be imaginary, right? So if this is negative, you square root that negative number, it's going to be imaginary. That's why it's two non-real solutions here, okay? Now, how do we get then 2 or 1 depending on the zeros here? Well, let's take a look. So if this is greater than 0, all right, we will square root that, all right? And we can square root a positive number. Why do we get two solutions? Well, it's right here because of the plus or minus. We're going to take this negative b, we're going to add the square root of this. We're also going to have a solution where we take negative b and subtract the square root of this, okay? That's where we get the two solutions, okay? If this is positive, the square root of a positive number is going to be a positive number, and we're going to add that, and then we'll subtract it, and that gives us our two numbers, our two answers. And then one solution, if this is equal to 0, because what is the square root of 0? If b squared minus 4ac is 0, and I take the square root of it, what is the square root of 0? 0, right, okay? And if you add 0 or subtract 0, does that change this value here at all? If I add 0 or if I subtract 0, does that change the value of negative b? No. If I add 0 to negative b, or if I subtract 0 from negative b, does it change negative b's value? Gonna fall asleep? Some of you already have. All right. If I add 0 to negative b, or if I subtract 0 from negative b, does it change negative b's value? No, it doesn't, right? Okay? So, adding or subtracting 0, this doesn't change at all, right? It doesn't matter if I add or subtract 0. So, I'm only going to get one solution here. It's going to be negative b over 2a, because I'm not changing negative b, right? It's going to be plus 0 or minus 0. It still is negative b over 2a. So, we get the same solution. Whereas, with this one, when it's greater than 0, I'm going to square root a positive number. I'll have some other positive number as my answer. I'm going to add that and subtract it. That's going to result in two different solutions there, okay? So let's just try and see this here in action. Okay, let's just try and see this here in action. Okay, so let's just see an example or two here. Okay, determine the number of solutions, we'll say, for these examples here. Okay. Okay, number 1. Let's try this one. X squared plus 8x plus 17 equals 0. Okay. So first of all, is this in standard form? Is it in the form that we need, right? Well, it's equal to 0 here, and all of our terms are combined here, and so yes, it is, okay? Is this a quadratic equation? Yeah, what makes it quadratic? The square, exactly right. The x squared, that's our highest degree term, highest power term. So yep, x squared does make it quadratic there. Very good. Okay, so let's now determine the number of solutions, right? Okay, so in this problem here, Geo, what is my a?
X squared.
Okay, but what's the number in front of the x squared? A 1, right? So right there, there's my a. It's a 1, okay? So a equals 1. All right, very good. Kyler, what's my b?
B.
What number is it?
8.
What? Yeah, but b, right? Which one of these numbers is b?
That would be next to
The 8, exactly right. So that's the b right there. So b equals 8, okay? And then Braylon, what's our c here? 17, you got it, okay? All right, we want to be able to identify those. Now, the determinant, remember, is just this part right inside the square root here. And so we're going to do, okay, b squared minus 4ac. So we'll plug b in for the b there. So it's going to be 8 squared minus 4 times a, which is 1, times c, which is 17 in this case. Okay? So, let's simplify it here. 8 squared, 64, right? 4 times 1, 4, times 17, 68. Okay. Make sure I did that right here. Pretty sure I did. Yes. Okay. What's 4 minus 68? Negative 4. Okay. So negative 4, is that greater than 0, equal to 0, less than 0? Less than. So that is our third situation right here, right? B squared minus 4ac is less than 0. Bless you. So we would expect here to have how many solutions? 2. And what kind of solutions? 2 non-real solutions, okay? So 2 non-real solutions. Yep. Yeah, go ahead. Okay. 2 non-real solutions. Now, again, that was pretty quick, right? That was pretty quick. All we had to do was just identify the numbers, plug them in, and see if it was greater than 0, equal to 0, less than 0. But you can see also we kind of sacrificed something, right? Yes, we were able to come up with an answer, but we don't know the exact answers. We just know how many there are, 2 non-real, right? So we gain speed, we lose accuracy, right? We can more quickly do this calculation, but we don't know the actual solutions. We just know that there's 2 non-real solutions. Okay? All right, let's look at another one here. Right? X squared plus 10x minus 7 equals 0. Okay. So, again, we just want to determine the number of solutions here. Wyatt, what is our A here in number 2? Okay, what's the number in front of it, though? 1. So we got a 1 there. That's our A. What's our B, Wyatt? 10. Again, just the coefficient, so just the 10 there. And then what's our C? Negative 7. Exactly right. Okay. And so we have A is 1, B is 10, C is negative 7. And so we'll just type this or plug this into our discriminant here. Okay. 10 squared minus 4 times 1 times negative 7. Okay. Now, can anyone just kind of like mental math this real quick and see whether it's going to be positive, negative, or 0? Positive? How do we know? Very good. Yes. Okay, so if you look here, right, we have negative 4 times positive 1, so it'll still be negative, times a negative 7, it's going to be positive. And then 10, anything squared, right, any 10, like 10 squared, that's going to be positive. So we have a positive plus a positive. You know this is going to be greater than 0. So in other words, you don't have to, and I'm not going to make you, okay, you don't have to simplify that. We can go ahead and say right away that this is greater than 0. All right, just based off of that reasoning, right? If this is positive, and we're going to subtract a negative number, right? Or again, it'll be negative 4 times negative 7, so it's positive, right? So these two are positive, they're going to combine together. That's got to be greater than 0. We don't even have to do the math there, okay? So if you can see that, feel free to stop right there. You don't need to simplify this down. If you can see right off the bat, oh, this is going to be positive, then just say so and be done with it. Since it's positive, what does that mean? How many solutions do we have? Since it's greater than 0, our discriminant is greater than 0, how many solutions do we have? 2 and 2 real ones. Yeah, 2 real solutions. Okay, that's all there is to it. Okay, 2 real solutions. Now, I'm going to show you real quick. I want to connect this with our graphing calculator stuff. All right? How can we represent this visually with our graphing calculator? Well, let me do the 2 real ones first, and then I'll show you the imaginary ones. Okay? So, x squared plus 10x minus 7. Okay? So, let's say I wanted to look at the graph of this. Okay? Oh, doggone it. I got to fix my window here. Let me go negative 15. Okay, that's good enough for what we need. All right? I want to know when this is equal to 0, right? And I have it graphed right here. I have the x squared plus 10x minus 7 graphed right here. Okay? Where am I looking to see when it equals 0? When it does what? Where will this graph, where it crosses what? Yes, very good, Mike. Yes. Okay, we're across the x-axis. I can see it crosses 1, 2 times. There's my 2 real solutions. Okay? There's one solution there. There's one solution there. If you wanted to find the exact solutions, remember you can always do second trace. Use the 0 command. Okay? And then I got an arrow over here until I see it. Okay? Go to the left of your 0 that you want to find. Go to the right of your 0 and hit enter. And then guess it, and then there it is. Okay, you can see there's one of my real solutions there. Okay, now let's see what happens with the 2 non-real solutions. What does that look like? So again, I'll go back to my quadratic here. X squared plus 8x plus 17. Graph this. Let me do a zoom 6 here. Okay, now, Mike said, right, that this is going to equal 0 where it crosses the x-axis. Where does this cross the x-axis? It doesn't. That's why we have 2 non-real solutions. If it crosses the x-axis or if it touches the x-axis, those are real solutions because the x-axis is real numbers. If we have non-real, they're going to be imaginary, right? And so imaginary numbers, we can't graph those. And so you see it doesn't show up. It doesn't cross the x-axis. So there's your 2 non-real solutions. Okay, it doesn't cross the x-axis there. So you can confirm by graphing if you need to, okay? If you can confirm by graphing. All right, let's do one more here together, and then we'll go on to the quadratic formula. Oops, I can keep the number direction. Yes, yeah, go ahead. All right, let's do one more here. Okay, one more. How about this one? Okay. Is this quadratic? Yes, it is. How can we tell? It's got the x squared, right? So we can use all of our different quadratic stuff here, but it's kind of in a weird format, right? Is this in standard form? Like, do we have ax squared plus bx plus c here? No. So how do I need to manipulate this in order to get it into that form that we need? Move everything to one side. Exactly right. That's crucial here. So what would I need to do? What do you want to move here? Add x squared to both sides. Did anyone want to subtract 50x to both sides? Subtract 50x on both sides? Okay. The answer is you can do either. Either one's okay. Either one's okay. Okay? But I like keeping the x squared a positive coefficient. So yeah, let's add x squared over here. So we get x squared plus 50x equals 0. Okay? Very good. So then what is my a here, Chris? What number is a? Okay, but again, what number is it? What's the coefficient here? A 1, yeah, 1. Okay. What is the b here, Chris? 50, very good. So a is 1, b is 50. Chris, what's the c? Very good. There isn't one, right? So it's 0. Okay. Let's see what happens. All right. I'm going to plug this into my discriminant. So again, b squared minus 4 times a times c. So b squared is 50 squared minus 4 times a, which is 1, times c, which is 0. Okay. Super easy here. right? Mental math it. Is it going to be positive, negative, or 0? Anybody? Is this going to be positive, negative, or 0? Negative? How'd you get negative? Okay, so where's my second subtraction sign here? Oh, I see. You got one subtraction. Right. Yeah. What's this value going to be, though? It's going to be 0. So I have 50 squared minus 0. Is this going to be positive, negative, or 0? It's going to be positive, because this 50 squared is going to be positive, right? It's a positive number. I'm going to subtract 4 times 1 times 0, but that's just 0, right? If you multiply this three numbers by 0 there, or these two numbers by 0, you get 0. So 50 squared minus 0 is going to be 50 squared, which is positive. That's greater than 0. Okay? This is equal to 0, but then 50 squared minus that will be positive. Okay? Again, if you find yourself making mistakes, just simplify it out. You can just do it and type that in your calculator. See if it's greater than 0, less than 0, or equal to 0. Okay? So since this is greater than 0, how many solutions do we have? Two real solutions. 2 real solutions. Okay, 2 real solutions. Now, why do we do this when we can solve any quadratic that gets thrown at us, right? Why do we even bother with this? Well, sometimes we're just interested if there is a solution. We don't necessarily care what the solution is, right? Sometimes we're interested in just if there is a solution. We don't always care what the solution is. Let me show you an example. Actually, let me give you one to try here, and then I'll show you what I mean here in a second. Okay, so let me give you one to try. All right. Let's say. Okay, you guys try this one here. Just real quick, make sure you're okay. Oh, hello, Julie. Thank you, sir. They're doing SAT pre-registration right now, but you'll probably have to do that another time, I guess, because I guess you're probably too late for that. All right, here's one for y'all to try. Okay. Try negative 5x squared minus 2x minus 8 equals 0. Okay, and again, just use the discriminant there. Okay, so go ahead and try that real quick. See what you come up with. Okay. Identify your A, B, and C. And give me a solution. Identify your A, your B, and your C, and then see if they're greater than 0, less than 0, equal to 0. After you simplify. B squared minus 4AC, right, is the discriminant. Julie? Very good. Thank you, sir. Oh, you just find it there, friend? I guess I should come around and check here real quick. Two real, one real, two non-real. Which one is it? Yeah, you're getting this okay? Yeah. You don't need to use quadratic formula here. I just want you to use the discriminant. So it's just b squared minus 4ac. That's all you got to do. Okay, just like we've been doing. You're going to have to use the full quadratic formula. Yeah, looks good. Very good, Gio. So just this part. So 4 minus 4 times negative 5 times negative 8. You don't need the square root of the 2 plus or minus or anything like that. Okay. Let's take a look here. See how we did. Okay. A is -5, B is -2, C is -8. Okay, that's crucial that you identify those first, right? -5, -2, -8. Okay. Oops, sorry. Okay. So A is -5, B -2, C -8. We'll plug in then B squared. So B is -2 squared minus 4 times A times C. Okay. -2 squared is 4. And then -4 times -5 times -8 is -160. 4 minus 160 is going to be less than 0. So that's why it's two non-real solutions there. Two non-real solutions. Okay, questions on any of that? We're going to move into the quadratic formula here then. Yeah, Julie. Summarize real quick? Sure. All right. So, what we're looking to do here.
I came to get Ashley's stuff.
You came to get Ashley's stuff?
Yeah.
Gotcha.
Where does she sit?
Back there in the corner.
Alright.
Is she not feeling well?
No, but they told her that she's going to have to stay there for a little bit longer, so she asked me to get her stuff.
Okay. Very good. So what we're doing here, Julian, real quick, just to kind of get you caught back up to speed here. We're looking at the discriminant, right, and solving quadratic equation using the quadratic formula. So we're about to get into this part, solving using the quadratic formula, okay? But first, I wanted to just highlight this thing called the discriminant, right? The discriminant is this piece of the quadratic formula right here, the b squared minus 4ac. Okay, go ahead.
So you find out those letters in front of it.
Mm-hmm. Yep, and then you do b squared. Well, so I would say, so good question, right? So it depends on what the sign is. So if you do -4 times a times c, and your answer is negative, then you can add it. You can say if you want to. So it'll be b squared. Yeah, whatever. So whenever, yeah, b squared plus whatever -4 times a times c is. Yes, if you want to think of it that way. Okay. If A was positive and C was negative, but then you would have negative times that -4, which would then become positive. So it would be then plus. Yep. And again, if you're unsure, you can like type literally this whole mess in your calculator. Just type in 10 squared minus 4 times 1 times -7 in the calculator. It will multiply it out correctly. Correct. You don't need it. You don't need it. Okay? Just this is enough to tell us whether we have 2 real, 1 real, or 2 non-real solutions. Okay. Now, Julian, eventually when we actually use the quadratic formula, yes, you're going to use the square root and stuff because the quadratic formula, we use that to find the exact answers. Right now, we're not finding exact answers. We're just finding how many and what kind of answers they're going to be. Okay. And that's what math eventually becomes sometimes. If you go far enough in math, eventually you get to things where it's like, well, sometimes we can't find the actual solutions, but we try to do the best to just describe what the solutions can be. Okay, so this is like part of analysis, just like us analyzing quadratic equations and stuff.
So for 2 non-real numbers, like imaginary numbers?
Yes, exactly right. Yes. Yep, exactly. Which makes sense because if this is less than 0, right, that means it's negative. And when you take the square root of a negative number, you get an imaginary number. And that's where it comes from. Okay, so it's all related. All right, let me just show you briefly here a situation where it might be helpful to use the discriminant, right? Okay, where it's not necessary to solve, and we can just do this with the discriminant. Okay, so let me just show you what I mean by that. Okay. Okay, A ball is thrown in the air with an initial vertical velocity of 14 meters per second from an initial height of 2 meters. The ball's height, h in meters, at time t in seconds, can be modeled by the quadratic function this. So this is like the ball's height over time, okay, for this particular situation. The question is, does the ball reach a height of 12 meters? Okay, now, how would we set that up here? If this is the height of the ball over time, and we want to know, does the ball reach a height of 12 meters, how can we set up the situation here? What can we write to relate these things, to figure that out? Yeah, make it equal 12, exactly right, okay? And so let me just show you here. So we could say negative 4.9 t squared plus 14t plus 2 equals 12. Okay? Now, the question does not ask at what time the ball reaches a height of 12. The question only asks, does the ball reach a height of 12 meters? So in other words, this is yes or no. We're not trying to find a specific value here. Okay? So, how can we maybe use the discriminant here to solve this? Well, first of all, are we in the appropriate form to use the discriminant right now? What should this be equal to? If we need to make it equal 0 before we can use the discriminant here. So we'll subtract the 12 from both sides. Okay, negative 4.9 t squared plus 14t, and then 2 minus 12 is negative 10. Okay, now let's use the discriminant. Let's use the discriminant, okay? So, I'll zoom out here and go over to here. Okay, so it's, again, b squared minus 4 times a times c, right? So our b here is what? 14. Okay, what's our a here? Negative 4.9. And what is our c here? What's c? Negative 10. Okay, so let's see what happens when we just use the discriminant here. All right, I'm just going to type this mess in my calculator just to show you guys you can do that. So 14 squared, okay, minus 4, negative 4.9, negative 10. Literally just use the parentheses there like they've got it. And we get 0. Okay, we get 0 there. When you get 0 for your discriminant, what does that mean? One real solution. So, does the ball reach a height of 12 meters? The discriminant indicates we have one real solution to this equation. So, does the ball reach a height of 12 meters? Yes. Why? Because there's one real solution. There's one real solution, right? So, is there a solution to this equation, right? Which is the height of the ball when it's equal to 12, right? There's a 0 discriminant, which means there's one real solution. So there is one t value that makes this true. Therefore, the ball does reach a height of 12 meters. So we were able to skip actually solving it. Okay, we were just trying to see yes or no. Does it reach a height of 12 meters? The answer is yes, it does. Okay, yes, it does. Okay, yes, it does. All right. So. So that's an example of how you can use the discriminant, okay, to kind of quickly answer a question, right? That was much quicker than using the quadratic formula, which we're going to do right now. Okay? So, let's use the quadratic formula here. Okay, and let me do it to, let's see here. I'll do it with some of the earlier ones that I gave you guys already. Let's do this one, okay? Okay, so now we're going to solve the equation. Question? You want to wait just for this first one just to make sure you're okay, and then I'll let you go? All right, just because I don't want you to miss the quadratic formula stuff. Excuse me. Okay, we'll do the second example that I gave you, x squared plus 10x minus 7. So first, before we go into the quadratic formula, I just want to remind you, right? When you're out in the wild and you're just trying to do math, right? You're trying to solve some equations and stuff like that, all right? One option you have here is to graph this, right? You graph the left-hand side, graph the right-hand side, find the point of intersection, that'll give you your solution, right? You can do that if you have your graphing calculator handy, right? Alternatively, you can try and factor this, but I don't think this factors. I'm looking at it right now, doesn't look like it factors, okay? You could complete the square like we did in the warm-up, okay? Which I erased, but we did in the warm-up. You complete the square and then solve it that way, okay? And then, of course, every quadratic equation can be solved using the quadratic formula. And that's what we're going to do right now, okay? We save this one for last. It's the most powerful, okay? But it's also, well, it's got some work involved with it, right? So, again, here's the formula. Okay? Yes? Yes. Yep. And we'll hopefully see some examples of that here, okay? So, right, we need to identify our A, B, and C. Now, first of all, I notice this is equal to 0, right? If it's not equal to 0, it needs to be in order to solve this, right? So, in other words, you need to have this in standard form. It needs to be equal to 0. Okay, it is equal to 0, so we're good to go here, okay? What is our A here? 1. What's our B? 10. What's our C? -7. All right, Kyler, time to put the phone away, bud. Put it away. You need to pay attention, okay? I need you listening in. Okay? So, let's use the quadratic formula now. All right? X equals, all right, negative b. So negative in parentheses 10. Okay? Plus or minus the square root b squared. So in parentheses 10 squared minus 4 times a, which is what? What was a again? 1 times c. What was c again? -7. All over 2 times a. What was a again? 1. Okay. That looks like a mess to simplify, doesn't it? Yeah. Okay. Do you recognize the discriminant in here? There it is, b squared minus 4ac, right in there. Okay. How did we simplify the discriminant before? What did we use? How did we simplify the discriminant before? What did we use? Plug it into your calculator, folks. Okay? Don't use a square root. The calculator won't simplify the square root for you. We'll have to worry about that later. But just plug this into your calculator. Plug the discriminant in. Do 10 squared minus 4 times 1 times -7, right? Just type it in. 10, actually use parentheses, 10 squared minus 4 times 1 times -7, right? I'm just typing in the discriminant right there. Hit enter. 128. Now, that doesn't look so bad, does it? Okay. Did that take much effort? Just type in stuff in your calculator. That's all you got to do. Discriminant in the calculator, and it simplifies right down to that. Okay. Let's simplify it a little bit more. When you divide a sum or a difference, okay, by a number, you can break up that difference or sum. So I can make it -10 over 2 plus or minus the square root of 128 over 2, like that. Okay. What's the benefit of doing that? Well, what's -10 divided by 2 there? It's -5, right? And again, if you don't know that, type in your calculator. Okay. This, well, that's a bit trickier, isn't it? Okay. I'm going to go ahead and change that divide by 2 to just a 1/2 there. That might be a better idea. Okay. Remember, dividing by something by 2 is the same as multiplying it by 1/2. All right. And that's not that bad either, right? Now, square root of 128. Are there any perfect squares that divide 128? I think so. Let's guess and check one. What would be a good one to guess and check here to see if it divides it? You want to try 64? Ooh, that's a good one. Yeah, that's good. Good job there, okay? I was going to say 4. But hey, 64 is even better. because it will take care of more of it. Okay, so 64 is the perfect square of 8. Yeah. So then this is equal to -5 plus or minus 1/2 times the square root of 64 times the square root of 2. Okay. What is the square root of 64? 8, we said, right? So it's plus or minus 1/2 times 8 times the square root of 2. And what's 1/2 times 8? What's half of 8? 4, right? So 1/2 times 8 is 4. And there's our final answer. Okay? If you can get to here, that's good, but I want you to be able to simplify too. Okay? If you can get to here, that's not then you don't have a quadratic formula problem. Okay? If you can get to here, then you do not have a quadratic formula problem. You have an algebra simplification problem if you can't get to here. Okay? So if you can get to here, you don't have a quadratic formula problem. You have an algebra and simplification problem if you have trouble getting to here. Okay? So keep that in mind. Okay? Questions on any of that? All right? Shall we try another one? We'll do one more here and let you guys get started on the assignments. Okay? All right. Let's see. Something that's nice. I don't have a nice one, do I? All right, let me try this one. Let's do x squared minus 4x plus 4. Okay, x squared minus 4x plus 4. Okay, again, we're going to solve it using the quadratic formula. Okay. Before I go to solve it, first, is it quadratic? Yes, it's got an x squared term, right, as the highest power. Is it in the right form? Yes, because it's equal to 0, right? Okay, it's got to be equal to 0. So it must be quadratic, right? You got to have an x squared in there somewhere to use quadratic formula, and it's got to be equal to 0. So yes, all right, quadratic formula. Here we go. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. If you have trouble memorizing this, and I'm not going to make you memorize it, okay? But if you want to, all right, there's like a bajillion songs on YouTube, all right, that are people trying to become internet famous, okay, that want to make their own quadratic formula song. You can even sing this to like the tune of "Pop Goes the Weasel." It's like x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right. So there you go, right? Don't ever say I didn't do anything for you, all right? So, all right, what is... I know, Mr. Widd, why aren't you out singing on TV or something right now? I don't know. You know, it's just... All right, what's that? Yeah, exactly. I should make my own video and become internet famous, okay? What's our A here? One. I guess I did record this. You can always go back and look at it that way, but anyway. All right, what's B? -4. Very good. -4. What's C? 4. All right, plug them in. X equals -(-4). Okay, so there's the negative in front of the B because of the formula, but then B is also -4, so it's -4. Yes, yes. Okay, we're subbing in, so it's -4. Okay, this is what Julian was asking about earlier. Okay, for those of you that were thinking along with us there. Okay, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 4. All over 2a, which is 1. Okay. All right, first step. We're going to simplify some of this using our calculator. Which part are we going to simplify using our calculator? Yes, the thing under the square root, the discriminant, right? We're going to simplify the discriminant. So type it in. Negative 4 squared. Oops, I'm off the screen. There we go. Negative 4 squared minus 4 times 1 times 4. Just like that. See it? Yeah? Hit enter. Hey, 0. That's nice. That's nice. Okay. So let's simplify this too. So what's negative 4 become? 4. Positive 4. Plus or minus. This discriminant was 0, so it's going to be the square root of 0 all over, what's 2 times 1? 2. Okay. What's the square root of 0? 0. What's 4 plus or 4 minus 0 going to be? 4. We have one answer there, 2. Okay? So if we were to do the discriminant here, the discriminant would indicate that we would have one real solution. So our discriminant here is 0, right? And that indicates one real solution. And there is that one real solution. Here, right, our discriminant is positive, right? Root 128, that's positive. So that indicates that we have 2 real solutions, and there are the 2 real solutions. Negative 5 plus 4 root 2, negative 5 minus 4 root 2. Okay? All right. Questions on any of that? Okay. I'm going to stop the video there then. All right, for those of you that are just getting back here, I'm going to hold off because I think there's still a few people out. But if we have enough time, we'll do something here.